Yeah. Today we'll start with the new topic, that is Verilog. Introduction to the Verilog. Okay. Introduction to Verilog. Okay. Once again. Yeah. Yeah. Introduction to Verilog. So, before that, we have programming languages. No, programming languages. Okay. What are the programming languages? You have software language. Software. What are the software languages? Can you say? What are the software languages? C, C++, Java, yeah, Python. These are the software languages. .NET, okay. All are the software languages, okay. And next you have hardware descriptive language. Hardware descriptive language, okay. Hardware descriptive language. So in this, this we call as HDLs, okay. In this you will get Verilog and VHDL, and next you have SystemVerilog. Okay. So now, can you say what is the difference between software language and hardware descriptive language? Can you say? Okay, okay. Software languages are nothing but they will develop the software engineers. They will develop the application. Okay, they will develop the application only. Suppose let us take railway ticketing system is there. Railway ticketing system, they will develop the application and they will give it to the railway employees. So what happens, depending on the requirement, if you open the reservation, you will see wherever the waiting list and all those interface you will get, no. Okay, bank if you see. So bank interface is different. Okay, the software people will give the application or interface to the bank people, so that bank people can access the accounts and all those, what are the deposits, balance, all those uh, sheets, they will access, no. So that means they will provide only application only. Whereas hardware descriptive language, we can by using the HDL, we can make hardware. Okay, we can make hardware. This software languages, software people, they will not make an hardware, just they will develop the application only. Okay, so this is the difference between software language and hardware descriptive language. Okay, so coming to Verilog. Okay, Verilog, it is like it is standardized or came into market around 2001. Okay, it will follow 2001, it will follow C syntax. Okay, C syntax, and and this is easy to learn. Okay, and some level of abstractions are there, like four levels of abstractions are there, that we'll discuss. Okay, and VHDL, do you know what is the full form of VHDL? Very high speed integrated circuits hardware descriptive language. Okay, very high speed integrated circuit hardware descriptive language. So this is standardized, or there is a triple IEEE. So that is standardized around 1999. This is old language only. So this will follow the old language like ADA and Pascal. Okay, Pascal, 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 and hard syntax will be there. Okay, hard syntax will be there, and this is hard to learn. Okay, this is hard to learn. Okay, and so here, suppose example, if you take simple AND gate is there. AND gate, So inputs are A and B, and output is nothing but A and B. So with the 3 lines of code you can write in Verilog, but in VHDL it will take 12 lines of code. Okay. And next, system Verilog means nowadays they are using system Verilog 30% they are using for design also, but 90% they will use for verification. 90% they will use for the verification. Okay. Verification means we already seen like half adder, full adder. Suppose if you take half adder, so half adder in digital, you already seen like how many inputs and how many outputs, two inputs and two outputs, and A, B, sum and carry, and you got the logic expression. You draw the logic diagram, no? So this is verifying is nothing but whether your circuit is working properly or not. So that is nothing but verification. Okay, that also we'll discuss. Okay, so suppose do you understood the difference between software language and hardware descriptive language? Okay. Next, if you take suppose in digital we already seen full adder is there. Okay, full adder you know. Suppose it consists of three inputs are there. Three inputs means let us take A, B, and C in. Okay, you know that sum equal to what? A XOR B XOR C in. No? Okay, so suppose if you write the code in HDL, if you write the code in HDL, there are some EDA tools are there. EDA tools. What are the EDA tools? EDA tools are nothing but electronic design automation tools. Okay, this EDA tools convert your code, whatever your code, into what gate level netlist. Gate level netlist. That means the circuit is in terms of gates only. Okay. Okay. So hardware descriptive language is nothing but whatever the circuits you studied, you are describing in terms of textual form. That is nothing but hardware descriptive language. Hmm. Yeah. Yeah. So that means so I will write here converting the code, whatever the HDL code is there, into gate level netlist, into gate level netlist. That is nothing but we call as a important term, that is synthesis. What is this? Synthesis. Synthesis is nothing. Synthesis. Yeah, synthesis. You are converting your code into gate level netlist, or we can call as hardware also. Is it fine? Okay. Yeah. C nowadays they are using C or C++ also. So this is we can call as high level synthesis. This is nothing but high level synthesis. Okay. So high level synthesis. In the high level synthesis, what they are doing means this C and C++ is converted into Verilog. Again, Verilog is converted into gate level netlist. Netlist. Gate level netlist. Is it fine? Okay. Next, if you see the level of abstraction. Okay. So what is the level of abstraction? So there is an abstraction. Okay, abstraction level is there. So what is this abstraction means? The process of representing the digital system design at a certain level without exposing the underlying implementation details. So that means in the level of abstraction there are two types are there. Top down approach, and next one is bottom up approach. Bottom up approach. Okay. So if you see the top down approach, what will be there? So if you see the top down approach, first you have system. Next you have system is again divided into modules. Modules are divided into gates. Gates are divided into transistors. Did you understand top down approach? Okay, first system is what? Normally CPU. Okay, CPU modules are nothing but it is in terms of what? Either combinational or sequential circuits. And gates means you already seen, no? And gate, NAND gate. Okay, CMOS means in terms of transistors. CMOS circuits. Transistors are nothing but in terms of CMOS circuits we will design. So this is nothing but top down approach. Okay, bottom up approach means first it will be transistor, and next you have gates, and next with the help of gates you will develop the modules. Okay, and with the help of the modules you will develop the system. This is nothing but bottom up approach. Bottom up approach. Okay, so mostly in the VLSI we will use a top down approach only. We'll use this approach only. Okay, so we'll divide the system into modules and modules into gates and gates into transistors. Is it fine? Okay, and coming to the main level of abstraction in Verilog. Okay, so what is the main level of abstraction means? There are uh, first circuit level. Okay, circuit level, and next you have gate level, gate level, and next you have data flow level, data flow level, and next you have behavioral level. Okay, behavioral level. Okay, so behavioral level, these two combinedly we call as RTL level. RTL level. So what is this RTL? RTL is nothing but register transfer level. What is this? Register transfer level. Register transfer level means, so normally your code is converted into what? Gate level netlist, no? Okay, so normal netlist. Normally it is in terms of D flip flop. Okay, so it shows that how the data is transmitting through the circuits is nothing but RTL. RTL is nothing but register transfer level. Is it fine? Okay, and next circuit level means what? So circuit level means you are representing in terms of first circuit level. Okay, circuit level means we are representing your code. Okay, your code in terms of transistor, in terms of what? Transistor. Okay, that is nothing but circuit level. Okay, circuit level. Okay, and next is gate level. Gate level means what? We are representing using logic gates. Okay, logic gates you are using. Okay, so there are some gate level primitives are there. So gate level primitives means already they are there in the standard library, like and, or, nor, NAND. Okay, and XOR. These are nothing but XNOR. These are the gate level primitives. Okay, gate level primitives. Okay, and next you have in the register transfer level, what you will get? RTL level. You have data flow level, data flow, and behavioral level. Okay, first we will see data flow modeling. Okay, data flow modeling means so first data flow modeling. So data flow modeling means we need to use a continuous assignment keyword. Okay, in the data flow modeling you need to use continuous assignment keyword. Okay, assignment keyword. Okay, that is what is the keyword you are using? Assign. You need to use a keyword called assign. Okay, if it is assign, suppose we represent in terms of expressions. Assign a equal to what? B plus C. Like this you need to represent. Okay, suppose if it is a half order circuit, how many inputs are there, how many outputs are there? Yeah, two inputs, two output, A, B, and S and C. Okay, Yeah, SS, C out. You can consider C also. So for the half adder, how to write? So that means I need to write the equation that is assign S equal to what? A XOR B. This is cap. I will tell you. These are nothing but bitwise XOR operation. Bitwise operators will discuss. And next assign carry equal to A and B like this. In terms of expressions, we are declaring that is nothing but what flow? Data flow modeling. Okay, is it fine? Do you understood? Okay. Next is behavioral modeling. So what is behavioral modeling? So behavioral modeling. Okay. So behavioral modeling means this is high level of modeling. Okay. So high level of modeling style. Okay, behavioral model. Okay. So here in this you are using procedural blocks. If it is a behavioral modeling, you need to use procedural blocks. Okay. What are the procedural blocks? You need to use the initial block and always block. Okay. Yeah, always block. Okay. Initial block means what? It will be executed only one time. During simulation time, it will execute only one time. Always block means it will execute repeatedly. Okay. It will execute repeatedly. Okay. Okay. This is non-synthesizable. What is non-synthesizable? By using initial, we cannot convert into hardware. We cannot convert into hardware. Okay. Then where we are using means we are using this initial block in the test benches. Okay. So always is synthesizable. Always is synthesizable. Okay. Synthesizable. And next we are using procedural statements. What are these procedural statements? Okay, procedural statements are like this controls the execution flow within the procedural blocks. Suppose in C language you studied if, case, and for, or while. These keywords used in the C language, no? So those are nothing but procedural statements. Is it fine? Okay. And procedural assignments. Procedural assignments. Okay. Procedural assignments are, there are two types are there. One is this will update the variable. One is blocking assignment. Blocking assignment. And next one is non-blocking assignment. Non-blocking assignment. Okay. So blocking assignment is what? Suppose like example, if you consider one like what we call, suppose toll gate is there. Okay. In the toll gate, what happens? Have you have you seen the toll gate? Yeah, first suppose there is a tag, so the tag will be identified means one car. So the gate will open, and after that gate will close, and after that the tag identifies means gate will open and one car will move. Is there any chance to overtake other cars? Cannot. You can't means the line by line you need to do. Okay, like that. So that is the example of what one blocking assignment. Blocking assignment means, so one instruction is executing, next instructions will be in which state means blocked state. Do you understood? Okay. Non-blocking means what? You have highway. Okay. This side cars are coming. This side cars parallelly. Cars or vehicles are moving on both directions. Okay. So that means this is nothing but this is parallel execution. Parallel execution. Okay. And one more difference between this software and hardware languages. Software language is sequential in nature. Sequential in nature means what? Serial. Serial means what? One after the other instruction that will be executed. And this HDL is a concurrent language, or parallel language. Parallelly, the instructions will be executed. Okay, that is the one more difference between software language and hardware descriptive language. Did you understood? Okay. So that means here in the behavioral modeling, you are going to use the procedural blocks. Those are initial and always block. Initial block is non-synthesizable, cannot convert into hardware, and always block is synthesizable. So initial block will be executed only one time, and always block is executed repeatedly. Okay, repeatedly, and you are using procedural statements like if else case for while repeat also you can use. Okay, repeat like that you are using. Okay, and procedural assignments mainly for designing the combinational circuits, we'll use non-blocking assignments. Okay. For designing the sequential circuits. Okay. For designing the sequential circuits, we are using blocking assignments. Is it fine? Did you understand? Okay. And next, basic syntax. Basic syntax. Okay. So, what is the basic syntax? Suppose a Verilog code will start with module. So that means if you Google it, the keywords in Verilog means you will get around keywords are 150 to 200 keywords you will get. Okay. So Verilog is a case sensitive. What is this? Verilog is case sensitive. Okay. So that means you need to use lowercase letters only. Okay. This is module. Module is a you need to use lowercase only. Lowercase only. And next, it will end with what? End module. So these are nothing but we call as keywords. These keywords are already present in the standard library. Okay, is it fine? It will start with a module and end with the end module. Okay, okay. Suppose if you take one half adder circuit is there. Okay, half adder. Half adder have how many inputs? Two inputs and two outputs. Okay, this is nothing but sum and this is carry. Okay, how to write for the Verilog code? Module, and this is module name or identifier HA, and here you need to declare port list. Okay, so that means how you are declaring, that is nothing but this is a keyword. No, this is a keyword. And what is this identifier? This is identifier. Okay, these are nothing but port list means you need to declare. So what are the port list? A, B, sum, comma, carry. Okay, and you have semicolon after the bracket. Okay, and next it will end with what? End module. For the end module, here no semicolon. Is it fine? Did you understand? Okay, and next uh, rules for identifiers. Identifiers are, I told you, this is identifier, or we can call as what? Module name. No, module name. Okay, so what are the rules for identifiers? Let us take for identifiers. Rules for identifiers. Okay, so what are the rules for identifiers? Means here I will write invalid identifiers, invalid identifiers, and valid identifiers, valid identifiers. Okay, identifiers. Okay, or module name also. Okay, so here we are writing for what? Half adder. No, so what are the invalid identifiers? No, there is no space between two letters. H space A, or it should not start with number 2H space A, or like 2HA. It should not start with a number. Okay, or like dollar HA, okay, and H hash A, okay. So that means here invalid identifiers are nothing but we cannot use, tell me, special symbols. uh, Symbols, yeah, we cannot use special symbols, okay. So that means like special characters, so special characters, and numbers at starting position, numbers numbers at starting position, okay, starting position, okay, and gaps between, okay, gaps in between, these are not allowed. Is it fine? Okay. And what are the valid identifiers? You have HA, okay, it will take, compiler will take H small a, and next HA2, okay. After this you can give the number, okay, and next you have HA2, okay, and underscore HA it will take. Suppose 2 cross 1 mux is there. Suppose if you are giving your identifier name as 2 cross 1 mux, is the compiler will take? No, why? Because it starts with the number. Suppose if you give underscore means it will take. Okay, yeah, underscore HA, and next HA underscore, and next you have yeah, next you have H underscore A. It will take. These are the valid identifiers. Is it fine? Do you understand? Okay. Yeah. Next, one second. I will add the page. Yeah. So next, port list declaration. Port list declaration. Okay. So there are like two styles are there for declaring the ports. First style one we'll see. Style one. Okay. Style one. Suppose same half adder I am taking. How many inputs and how many outputs? Two input, two output. Let us take the inputs are what, A, B, and output is what? Output is let us take sum comma carry I am taking. S comma C or sum comma carry. Okay. So here first style one means how I am declaring means module. What is my identifier name? HA. Okay. First you need to declare the ports. What are the ports? Sum comma carry. Okay. After this semicolon. Okay. And next separately I need to declare input A comma B and output, yeah, sum comma carry. This input and output are also keywords. Okay. Keywords. These are available in the standard library. Okay. And next style 2. What is this style 2 means? Suppose module HA, module HA, I am declaring, I can declare input and output within the bracket itself. Input A comma B, output sum comma carry. This is style 2. Okay. End module. Okay. So here you are writing end module. Here also you are writing some piece of code and next end module. There are some ports are there, in out ports. Those are acting as input as well as output. Okay. Input is a keyword. Output is also keyword, and in out is also a keyword. Okay. So this is acting as both input as well as output. That's why we call as in out. So did you understood? Okay. Yeah. Next, you have basic constructs. Basic constructs. Okay. So what are the basic constructs? Uh, Suppose like dollar display. So within this dollar display, whatever you are executing, that will be displayed. It's like a printf in C language. You studied C language or not? Printf in C language. Okay, okay. C language. Okay. So in C language, printf is nothing but whatever in the double quotes you are writing, that will be displayed. Dollar display. Okay. This is one type of system task. What is this? System task. Okay, system task. Okay. Like that, you have so many system tasks that we'll discuss. So in this, there are some escape identifiers are there. Suppose if I want blank space, we want blank space, I need to include with the backslash b. Okay. If you want tab, okay, you need to include with backslash t. And if you want a new line, so we need to include with backslash n. These are nothing but we call as escape identifiers. What are this? Escape identifiers. Okay. And next is these are the basic answers. Next is comments. What are comments? Comments. Have you used any programming language previously? Python also. Okay, Python also comments there. Comments are there. Okay. So yeah, comments are there. Here also same comments are there. Okay. So what these comments will do means these are increasing the readability, readability and understanding the line. Okay, and understanding the line, understanding that instruction. Okay, we can understand that instruction, and okay, understanding the line. Okay, and which are not executed by the compiler, which are not executed. Okay, so these comments will not execute by the compiler. Okay, just that will avoid, it will not execute. Okay, compiler will understand that is a comment. Okay, so the syntax for a single line comment is like this: forward slash. Okay, single line comment. Suppose if you consider module, let us take example. So but double forward slash a plus b. Okay, so that means this will be skipped by the compiler. This is single line comment. Single line comment. Okay, understood? So that means so you have first a single line comment, no? So how you are declaring single line comment? Single line comment, the syntax is like this. Syntax is forward slash, forward two slashes, and SLC, single line comment. Like this you can write. Okay. And next, multiple line comment. Okay. Multiple line comment means suppose it will be represented like this: forward slash star and some multiple lines are there. Okay, multiple lines. Suppose multiple lines are there. Again, it will end with what? Slash forward. Okay, slash forward. Okay, like this it will represent. Okay, and nesting is not allowed. Nesting is not allowed. Nesting is not allowed. Nesting is not allowed. What is nesting? Comments under comments. Yeah, suppose forward slash star is there. Okay, you wrote that is some comments. Again in this, again you are writing some more comments. Star slash. This is not allowed. Compiler will not take. Is it fine? Did you understand? Okay. Hmm. Next, you have the operators. Operators. So what are the operators? So you have first unary operator. Unary. Unary means what? Only one operand is there. One operand. One operand means we will discuss some reduction operators. Reduction operator is a unary operator. Okay. So reduction operator means you have not of A or and of A, NAND of A. Only one operand will be there. Understood? That is the unary operator. Okay. And next you have binary operator. Binary operator means how many operands? Two operands. Okay. Suppose we'll discuss A and B. This is a bitwise AND. Okay. And A or B. Okay. So these binary operators are used in logical operators, bitwise operators, equality operators, or logical equality and case equality, relational operators. So all those operators will use binary operators only. Okay, two operands are there. Okay, and ternary operator. Ternary operator means three operands. Okay, so three operands. So how it will be there means, suppose D equal to A, B, otherwise C, like this ternary. Okay, so we already see in the mux, no, 2 cross 1 mux. Okay, so 2 cross 1 mux. Suppose these two are inputs A and B, and selection line is yes, and output is what, Y. Okay, so the functionality of this 2 cross 1 mux I can write with ternary operator, only one line operator. How I can write? So I need to use assign also. Okay, I need to use assign. Before this, I need to use assign. Y equal to what? Y equal to yes, question mark. Which one will be connected? B. Otherwise A. Okay. So if S equal to 1, Y equal to what? B. Otherwise, if S equal to 0, Y equal to what? A. Okay. Depending on the selection line only, no? If S equal to 0, which one is connected? A is connected. If S equal to 1, which one is connected? B is connected. Okay. So, so this is about today's session. One second.